Welcome back everyone to another episode of Mastering Defence Infrastructure. So glad you're all here. We've got a big one today, loaded with insights on technical and delivery risks in defence projects. But before we dive into that, let's do a quick recap. Jess, want to set the scene?
Absolutely. Over the past few weeks, we've been building a framework for understanding risk management in defence infrastructure. In episode 6, we introduced the concept of project risk and broke down the components of the DIPRAC framework. Essentially, it's a structured approach to identifying and managing risks across all stages of a project.
Yeah, and what I loved about that one was seeing how it's not just a checklist, it's flexible, It adapts to different project scenarios. Anyway, keep us going.
Then in episode 8, we explored how location and environmental factors, things like climate, terrain, and even protected species, can significantly impact a project's delivery. If you remember, Darian, we talked about those defence projects up north, where the wet season can bring everything to a halt.
Oh yeah, the stuff nightmares are made of, right? Delayed schedules, flooded sites. It's all part of the challenge when you're working with defence estates. But this moves us into last week.
Exactly. Episode 8 covered stakeholder and coordination risks, successfully managing people, their expectations, and even conflicting timelines with other projects can honestly make or break your delivery. We shared strategies for clear communication and alignment that really resonated with our conversations, especially for multi-team projects.
Which basically means herding cats. But hey, it's doable. Alright, that's your quick recap of Phase 2 so far. Stick around because today we're diving into risks that really test your technical muscle. So, Jessica, let's really dive into today's theme. We've touched on some tough challenges before, but when it comes to technical risks in defence projects, it's a whole new level. Tight deadlines, massive expectations, and budgets that barely stretch. These aren't new, but how do they amplify the stakes here?
Well, these projects can be pretty unforgiving. With defence infrastructure, even a small mistake, say a fault in a critical storage design, could have ripple effects across operations, finances, or even national security. There's this zero-tolerance sort of environment, which is absolutely warranted considering what's on the line.
Yeah, no pressure. Just the entire country counting on you.
Exactly. And we're not just talking about costly mistakes or wasted time, right? It's about managing so many moving parts, complex designs, tight budgets, and schedules that do not allow for slippage, and ensuring they all work together seamlessly.
Right. And if you think these projects are just about keeping to a checklist, well, forget that notion. Defence estates push the boundaries of technology, engineering, and honestly, human patience. That means risk is like baked into the cake whether you like it or not.
And if risks aren't identified early, or worse, if they're ignored, they escalate. Take technology integration, for instance. If systems don't work well together, suddenly you're looking at delays, budget blowouts, or a product that can't even perform as promised.
Oh, let me guess. At that point, sorry doesn't cut it.
Exactly. What makes managing risks here unique is that it's not just about fixing problems as they arise. It's about anticipating them, getting the right level of expertise on your team, and weaving solutions directly into your planning and execution strategies. That approach is what separates successful projects from the "oh no, this is a catastrophe" ones.
Love that point, Jess. And honestly, it's like walking a tightrope. You've got these ambitious designs, state-of-the-art cooling or electromagnetic shielding. Sure, they sound exciting, but they also mean new risks to navigate. And combine that with having absolutely no room for testing failure, because downtime isn't just inconvenient, it could derail operations. Yeesh.
That's right, Darian. And every defence professional listening right now knows this. Mastering these risks isn't just a nice to have, it's a lifeline for ensuring projects run smoothly. And on that note, it's a perfect segue into exploring those technical challenges in more detail, isn't it?
Right, Jess. Picking up from what you said about navigating those ambitious designs, technical complexity really takes the spotlight, doesn't it? This is where defence infrastructure throws out the standard playbook and brings in the kind of engineering puzzles that make you go, wait, how is that even possible?
Absolutely, Darian. Defence projects are rarely simple because they often serve unique high-demand functions, and that's where technical complexity really ramps up. Take architectural challenges, for example. Think blast-resistant construction, Faraday cages for sensitive facilities, or extreme cooling needs for data centers. These aren't your average design requirements.
Oh, for sure. Forget trying to use cookie-cutter designs here. And the moment you need something like electromagnetic shielding, you've got to bring in specialists. Otherwise, you're staring down the risk of design flaws that'll haunt you mid-project. Yikes.
Exactly, and that's just the tip of the iceberg. Then there's structural complexity. Imagine designing a bunker to withstand a blast, or a column-free hangar for heavy aircraft. These demand not only intricate designs, but also materials that are up to the task.
And yeah, one tiny misstep there, like an underestimated load or weak soil conditions, can turn your whole project into a ticking time bomb. Literally sometimes.
Well said, but the challenges don't stop with architecture and structure. Building services complexity adds another layer. Sophisticated HVAC systems for biohazard containment, redundant power that never quits, and fire suppression systems specially designed for sensitive equipment like servers. These systems often need to work together seamlessly, and if not coordinated properly, well, let's just say the domino effect isn't pretty.
And that kind of complexity carries so much risk, right? Like if one part of the system's slightly off, say misaligned power specs, you're looking at underperformance or straight up failure. Talk about stress.
Exactly, and that's where teams need to flag complexity early. Take civil infrastructure as another example, building high-performance pavements in remote locations with less than ideal quarry material. That's why geotechnical investigations and expert pavement designers are critical.
Right. Those don't just save money. They rescue your project timeline from surprises that could stack delays. And just think, pairing dodgy soil conditions with tight deadlines is like adding fuel to the fire.
Absolutely. And finally, there's services infrastructure, like integrating defence facilities into broader IT, security networks and energy networks. These can involve anything from satellite communication links to AI-driven surveillance and uninterruptible power systems, and the risks often lie in getting new tech to play nice with legacy systems. Oversights here can cause major headaches later on.
And by major headaches, we mean missed deadlines, wasted budget, the whole 9 yards. Okay? So bottom line, step 1 in managing technical risks.
Flag the complexity early. Get your planning, your budget, and the right expertise in motion from the start, because waiting too long only narrows your options. It really sets the foundation for mitigating bigger risks down the line.
Speaking of managing complexity, Jess, one of the most critical aspects of defence projects has to be dealing with delivery pressures, tight timelines, strict budgets, and sky-high quality expectations. There's just no room for error, is there?
Exactly, Darian. Defence projects often operate in environments where everything from operational deadlines to budget ceilings is non-negotiable. Take Contribution Factor 1 or CF1 facilities, for instance. These are mission critical and quality expectations are through the roof because they simply cannot afford downtime or failures.
Yeah, like there's no wiggle room at all. One mistake and the ripple effects are massive. But tell me, how did teams handle this kind of stress?
Well, it's a balancing act, for sure. One key strategy is staging, breaking the project into smaller, manageable phases. Say you're building a secure facility but need the comms room operational ASAP. You prioritise that first, delivering critical functionality early while working on other areas later.
Oh yeah, I love that. Lessens the pressure and buys you wiggle room for the remaining tasks. It's like a win-win.
Exactly, but it only works when planned properly. Staging also helps with commissioning in phases, so you can test systems progressively rather than all at once. That said, if your team doesn't coordinate those stages meticulously, you risk creating more headaches than solutions.
And then there's the beast. Tight budgets. You ever feel like you're playing Jenga with costs, trying to save without toppling the whole project?
All the time. The trick is strict change control. You've got to guard against uncontrolled additions or scope creep. Clear processes for reviewing and approving changes combined with proper cost tracking can prevent surprises. And remember, once contingency gets eaten up, recovering takes a miracle.
Absolutely. And let's not forget the challenge of overlapping projects. Picture 2 teams fighting over the same access road or power supply. That coordination risk is no joke, right?
Right. That's why having an integrated master schedule or program governance is critical. It keeps all moving parts aligned and helps avoid conflicts. Communication between those teams has to be constant to avoid delays or errors stacking up.
And on top of all that, there's quality control. You can't just hope for it, you've got to champion it, especially with these CF1 builds. Imagine messing up on something modular or high-tech, like a gas suppression system. One misstep, and it's a compliance nightmare.
Exactly, and rigorous quality assurance is the only way through. Oversight at key milestones. Bringing in certifiers to check work aligns with defence standards or conducting thorough system tests before go live is non-negotiable. The sooner issues are flagged, the better.
Yeah, because let's face it, fixing things once they're built costs a fortune, okay? So staging, early procurement, QA, these seem like lifesavers in a high-pressure build. Anything else standing out?
Strong change control policies, like I said, are the backbone of keeping costs and timelines in check. And factoring in the impacts of concurrent projects upfront is critical. It's all about preventing last-minute surprises, Darian.
All right, Jess, speaking of preventing last-minute surprises, performance-based compliance is another major piece of the puzzle. It's one of those topics that seems boring on paper, but mess it up and suddenly your project's in ruins. I mean, compliance isn't just paperwork, is it?
Not at all, Darian. In defence projects especially, compliance can make or break delivery. It shouldn't be treated as some box-ticking exercise. It's about risk management. When you can't meet a prescriptive requirement like the NCC or MFPE, a performance-based solution comes into play to show you're still meeting the intent of those requirements.
Right? And it's not just a free pass either. You're basically saying, hey, my system is different, but here's why it still works. But if you skip the details, good luck getting that approved. Right?
Exactly. That's why involving the right experts early is so important. Fire engineers, for example, play a leading role when you're dealing with anything fire safety related. They help craft the analysis and liaise with defence stakeholders to make sure your performance solution holds water, or in this case, fire.
And what about DEEP? They're sort of like the great final authority on these things, aren't they?
Spot on. The Directorate of Estate Engineering Policy, or DEEP, reviews all non-standard compliance solutions in defence. Their endorsement is crucial before the building certifier can issue a building approval. Engaging DEEP early, providing complete documentation and addressing their feedback is non-negotiable if you want smooth sailing.
Yeah, and I love how the guidelines for certification and the BWM, Chapter 8 especially, lay out that roadmap so there's no guesswork. But hey, let's talk about those snags you hit if you don't keep everyone in the loop. Miscommunication's a biggie, isn't it?
Absolutely. If contractors or site supervisors aren't clear on what the performance solution requires, like specialised materials or exact installation guidelines, you can end up with invalid assumptions. And once those mistakes are built in, fixing them is exponentially harder and costlier. It's crucial the entire team knows the conditions up front.
And you just know that means documenting everything to the nines. Okay, but let's get real. What happens when something doesn't pass muster with DEEP or the certifier? Is it a game over moment?
Not necessarily, but it's a major delay. The project team might need to revisit their analysis, make changes, or add compensatory measures. That's why proper vetting and realistic justifications in your performance-based design brief are critical. You want as few surprises as possible during their review.
And don't forget what comes after. This stuff doesn't just disappear once you get the approval. Some solutions have ongoing dependencies like periodic testing or maintenance. Letting those slide over time could turn into a compliance nightmare.
That's so true, Darian. All the conditions tied to performance solutions should be crystal clear in the handover documentation. Whether it's for facility managers or end users, future oversight needs to stay baked into the system. Skipping that step risks undoing all the approval effort you put in during the build phase.
Solid takeaway. Compliance isn't one and done. You've got to treat it as an evolving part of risk management. And Jess, I think that brings us right back to the golden rule. Manage compliance like you'd manage a high-stakes risk, because that's exactly what it is.
Couldn't have said it better, Darian. So with performance-based compliance in the spotlight, it's the perfect time to move into how this all plays out in real projects, yeah?
All right, Jess. Since we're diving into how performance-based compliance plays out in real projects, Let's give our listeners something concrete to chew on. Picture this. You're managing an upgrade for a defence communications centre. A high-pressure project with tight timelines, tricky tech integrations, and, oh yeah, a supply chain that might have you calling manufacturers at midnight. Where do you even start to handle all that?
It's a great question, Darian, and honestly, these sorts of projects are great examples of why risk management has to start early. In this case, let's break it down. You've got a phased construction plan, building a new extension first, migrating operations, and then retrofitting the old facility. That means you can't treat this like a typical build. It's more of a live juggling act.
For sure. And the technology? You're talking state-of-the-art data hall cooling and RF shielding in a SCIF area. That's like inviting risk in for tea unless you've got specialists on speed dial, right?
Exactly. And you can't overlook the performance-based fire protection system. When you're dealing with server rooms, gas suppression is critical, but it also means you're relying on a solution that requires DEEP's approval. Get any of those details wrong, and you could find yourself in a compliance mess halfway through the project.
And then there's the external chaos. Supply chain delays on items like that monster generator or the RF shielding. Plus, don't forget overlapping projects on base. Imagine coordinating with the power system upgrade team to avoid your comm center going dark. Just thinking about it makes my head spin.
Completely agree, Darian. All of that points back to planning and communication being non-negotiable. But here's where I'd ask listeners, what would you do differently? Given the tight budget, the CF1 classification demanding 0 defects, and all these moving parts, how would you approach it?
Oh, and don't forget the human factor. You've got a limited pool of security-cleared technicians for the HVAC work in the SCIF. If you don't lock them in early, good luck scrambling to find replacements down the line.
That's a key point, Darian. It's not just about technical challenges. Workforce readiness plays a huge role. With all the risks at play here, from supply chain wobbliness to integrating systems with 0 downtime, this isn't the kind of project you can wing. So again, listeners, think on this. What would you prioritise, and how would you handle those compounding risks?
You're absolutely right, Jess. There's no room to wing it with so much at stake. If there's one takeaway from this discussion, it's that in defence projects, technical complexity and delivery pressure aren't just challenges, they're constants. The real game changer is how you anticipate and prepare for them, wouldn't you say?
Absolutely, Darian. Preparing for these risks is what separates successful projects from those that fall apart. You can't eliminate risks entirely, but you can certainly mitigate them by expecting them, getting the right experts in the room during the planning phase, and managing them as they arise.
And, let's not forget, tools can be your best mate here. BIM, FEMaster. These aren't just buzzwords. They give you clarity, like zooming in on the trouble spots early so you can deal with them before they become project breakers.
Exactly. And it's not just about the tools. Defence has such robust frameworks. From Aegis to deep reviews, these are more than just policies. They're roadmaps for navigating complexity. Remember, early communication with stakeholders and frequent engagement with deep can save you so many headaches down the line.
Totally. Especially when you're briefing contractors. You need everyone on the same page from day one. No keeping your cards close to your chest, or you'll end up buried in misunderstandings and delays.
Couldn't agree more. And here's the golden rule. Bring people into the process early. Your contractors, specialists, and defence engineers. If they know the scope, risks, and expectations up front, they're way more likely to deliver exactly what's needed.
Well said. And Jess, let's emphasise this for the audience. Delivery pressure doesn't mean you stop aiming high on quality. Things like staging for phased delivery and staying strict with QA processes are all about balance. It's how you meet tight schedules without compromise.
Exactly, and balance is key, whether that's juggling overlapping projects, coordinating with concurrent teams, or managing your budget properly. When priorities are clear and communication is constant, it's all doable. Even the craziest schedules can actually work.
Couldn't have wrapped it better myself. All right, folks, that's your takeaway. Be ready, use the tools, talk to your people, and stay on top of defence processes. It's how you keep the beast under control. All right, Jess, before we wrap up, let's quickly reflect on what we've covered. From handling risks to leveraging tools like BIM and FEMaster, and the importance of defence frameworks like Aegis and DEEP, We've really unpacked what successful project management looks like in defence infrastructure. What a ride.
Absolutely, Darian. I think the biggest takeaway is that managing technical and delivery risks isn't just about following processes, it's about embracing the challenges, thinking ahead, and leaning into the resources and teams around you. It's all connected.
Totally. And hey, if there's ever been an episode where feedback could make a difference, it's this one. You've all got unique experiences out there in defence infrastructure, and we'd love to hear your take. Got some insights or maybe a project anecdote to share? Drop it in the comments or in the forum if you're a DECnet Pro member.
Yes, please do, and DECnet Pro members should remember there's a quiz waiting for you on this week's lesson page. It's a great way to test your understanding of the concepts we've covered today. Plus, don't forget the scenario exercise. It's a fantastic way to deepen your learning by putting these ideas into practice.
Oh, and let's not shy away from spreading the word, folks. If you're finding these episodes useful, please share them with colleagues or anyone in the defence infrastructure space. The more, the merrier, right?
Exactly. Your input and engagement help us keep improving and ensure these discussions hit the mark. So don't hold back. Leave us some feedback, even if it's just a quick thought. It means the world to us.
All right, team. That's it from us today. Stay curious, stay proactive, and remember, success is all about managing risks before they manage you. We'll see you next time.
Take care, everyone, and good luck applying what you've learned. Bye for now.